Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia.
So hello and welcome to the HFE Hub podcast. I'm Kath Jones, and today I'm speaking with Dr. Ari Antonovsky, who I've had the pleasure of working with in the WA branch of HFESA for many years. Hello, Ari.
Hello, Kath. That's very kind of you to say that.
I'm looking forward to hearing more about your work as the project leader for the revision of the IEC International Standards on workplace dependability. But before I go into that, maybe we could start by hearing about your journey into human factors and ergonomics as a field of work.
Okay, well, it really was a fairly convoluted journey, I guess you could say. Obviously, didn't go straight into it. My original background and training back in the US was in materials engineering, so a bit of an obscure branch of engineering. So there wasn't a lot of that work in Australia when I came. And as everybody knows, the biggest show in town here in Western Australia is the mining industry. So I got involved in mining, morphed into what we call a maintenance engineer, and ended up working in research and development for CRA, as it was then, Conzig Rio Tinto Australia, and on various projects, and that was very interesting. But then Rio Tinto took over from the UK, and for better or worse, they didn't want Australians doing research and development, so a lot of us were put out on the street. And then I decided to continue with that sort of maintenance engineering work. So I went off working for a lot of the various mining sites, as it turned out, across Australia and Indonesia. And I was working now directly with the maintenance crew. So I was working with the people that did the hands-on sort of work. And what struck me most of all was that it wasn't about the machines. You know, engineering tends to be about technology, equipment, machines. The machines in mining have been around for about 150 years. So the issues really revolved around people and how people were organized and whether you gave them the tools to do the job, whether they had the right sort of information, communicated with, the training, all those sort of issues, which of course we recognize now as classic human factors issues. And so that dawned on me at one point, and I started reading about human factors and realized there was a lot of good research, a lot of good theory, a lot of good ideas in it, and decided to go off and do a course. So somebody pointed me in the direction of Professor Claire Pollock at Curtin University, and she was absolutely wonderful. And she saw where I was coming from and what I was wanting to do. But she said, there are no courses in human factors. You'll have to do a master's or a PhD. So I thought about it for a while and started down the road of doing a part-time PhD, and then realized that if I really wanted to do this seriously, I'd have to do it full-time and find somebody to sponsor it. So I was very lucky. Woodside came to the party, and Woodside said, yes, this is an idea that we're very interested in. We'll sponsor your PhD. And they did, and they gave me a desk, and they gave me, most of all, the most important thing for doing a PhD is access to people and access to data. And they gave me all that. I had the pleasure of going up to a lot of their sites offshore in Karratha, and interviewing people, and learned an incredible amount. I mean, it was really quite a wonderful experience. And out of that just came out feeling that I had learned something very useful about human factors. More to the point, marrying theory to practice. In other words, how people actually did work in the real world and relating that back to the theory and human factors. So having done that, I stayed on for another 2 years in Woodside, working on various human factors related projects for them. And then after that, went off to Boddington Gold and was working with them on ostensibly reliability engineering projects, but always with the human factors flavor. So as much as possible, I tried to bring the human factors concepts, the human factors components into the idea of it. And then from then on, I considered myself a human factors person, and opportunity came up to work on a Navy project, which I believe we're going to speak about later, with UWA. And so then I was embedded in the UWA psychology department, working on a number of projects for the Navy. By and large, always with an idea to work with people in the workplace, relate the human factors that they need to contend with, and then bring the theory to them, or bring what they're doing to the theory, so to speak. So I guess that's been my journey. It's a strange one to some people. One friend of mine said, psychology and engineering, is that even legal? And I said, well, it may seem like a strange thing, but there is an aspect to working with technology that, surprisingly enough, does involve people, and we have to recognize that and work with that. So that's been my journey into human factors.
And so it's a fascinating journey, Ari. And I think we often think of our psychology and engineering professions sometimes working in different fields, but I think the fact that when they work together, like you say, how people use a machine is almost just as important as the machine design itself and what stops them. So
it is. And one of the things that I experienced over the years was called in to do what we call root cause analysis. If you have a failure, so you bring people together who are knowledgeable, and you get to the point where hopefully you've worked out what the actual root causes of those failures were. And it's funny, the technical people will only look at the technical issues. If there's human error involved, that's as far as they'll look. And so I was always trying to bring in that additional human factors component and say, well, what about the factors behind the human factor? What are the systemic issues that might have been involved? What can we learn about this failure that might teach us something about how to improve the systems that we've got? And sometimes you meet resistance. Sometimes the engineers say, well, I don't want to know about any of that. Why did the machine break? Just let's fix the machine, make it bigger, make it uglier, make it more powerful, but I don't want to know about people. But then other people actually do say, yes, I suppose there might be an aspect to that. And one classic one, without giving too much away, was we were looking at gas gauges that were snapping off, the nuts were cracking and breaking off. And of course, that's a bit disconcerting for gas operation. And all the technical people were talking about spending millions of dollars to improve the nuts and use stronger materials and all this. And I said, well, have you actually gone out and seen if the fellows working in the field, have the training on these particular gauges? And the answer was, well, no. I mean, they're trained, they've had their apprenticeship, they should know what they're doing. Okay. And what about a torque setting? In other words, have you given them the correct sort of data that they need and information to actually tighten these properly? Well, no, I don't think so. Okay, you haven't done that. And do you know if they carry a torque wrench with them to have the proper tools to do the job? Oh, well, they should. But do you know if they do? Well, no. Okay, so you don't know if they have the right information, the right training, or the right tools, but you want to redesign a system at millions of dollars of cost before you check those things out. I think you should check those first. And so I think the light went on with that, and people were very happy to think, well, okay, there might be some other answers in all this.
That's a good advertisement for why human factors should be included in engineering degrees. The human error is often a misunderstood process. Look, I wanted to move on a little bit to your more recent work. I know that you've been working in the field of human factors and ergonomics for a while, but you've recently been leading a project which is revising international standards on the human aspects of workplace dependability. Could you tell me a little bit more about that, Ari?
Okay, that was an interesting one. I went to a conference and I was talking about the human factors work that I'd been doing. And somebody came up and approached me and said, we have a suite of dependability standards that we work on, but we have this one standard on human aspects of dependability, and we don't have anybody to work on that. There was one done back in 2010, and it seriously needs revision. And I said, oh, sounds like an interesting project. And I'd never worked on standards before, but I thought, well, give anything a go. It turns out it's an IEC standard, and the IEC is sort of a sister organization to ISO. And ISO tends to work more on the organizational level, people level. The IEC tends to be much more technically based standards. But again, they had this suite of dependability. It was mostly Australians working on this group of standards. And they were very keen that this one on human aspects had a champion, somebody to push it along. So I took that on, and I had a look at the old standard, the 2010, and it was very much old school. It was very much around, human error and how to measure how many times an error might get made. If somebody pushes a button 1,000 times, how many times will they push the wrong button at that level? It was very much based also on human-centric design, which is a very good thing, but a lot of workplaces obviously don't have the luxury of going back and redesigning their equipment. So essentially, human-centered design is good, but not necessarily the answer for a lot of people looking at workplace dependability. And there are a few other problems with it that I felt really needed to be brought up to date. There are a lot of new ideas in terms of a systems approach that really hadn't been incorporated into the standard. So I was very keen to bring in the organizational psychology and systems approach to that standard. And so that's what's been happening. The standard actually should be released in February next month, believe it or not. It's been about 6 years of work. So with people from all over the world weighing into that one. So I've had a lot of support. But essentially, what we've done is fully revamped it, and the idea is for that standard to be out in the workplace and for managers, project managers, engineers, to use it as a guide to looking at how their workplace, how the design of their workplace and how the design of the technology and how the people working in it could work better. So in other words, how they themselves can improve what they're dealing with in terms of workplace. So very excited about that. It'd be great to see it out there in print. And all I can say is it's been a very interesting project.
Oh, congratulations. There's a lot of work that went into it. I was interested, you mentioned that this IEC, there's a suite of dependability standards, and this is only just one of them looking at human aspects. What were some of the other standards around?
Well, when you talk about dependability, then you get into some of the common terms that engineers use, such as reliability, and that's a technical term that's measurable. You can talk about what level of reliability a particular piece of equipment has, so you can specify its reliability. Same thing with something called availability. So you have the inherent reliability, then you have the availability, so how much of the time the equipment actually is available, how much of the time it's broken down, how much of the time it's being maintained, how much of the time other work has to be done on it. So that's the availability. So, and there are a number of other concepts that go with this overall idea. But they obviously, at some point back in the annals of history, they decided that humans had to be part of this whole equation. So in addition to all the machine-related dependability standards, and there are about a dozen of those, they should have at least one to deal with humans. So it's the human aspects of dependability in the workplace. And again, I thought it really needed up to date because a lot of the concepts keep changing. The nice thing about human factors is there is a lot happening in this space. There are a lot of different human factors that we look at: supervision, training, communication, information, et cetera, human error. So it's very important that all these ideas be represented, all the ideas kind of find their way into it. So it's not a textbook. It is a standard. It's a guide. It's a way that somebody can pick up some thought through, has been put out there with all the other standards they're dealing with, and say, okay, this is the approach we want to take. So that's the idea of it.
So Ari Antonovsky single-handedly putting the human factors back into dependability standards.
Well, not single-handedly. I had some very good help from around Australia and New Zealand. Interestingly, this part of the world, it's an international standard, but this part of the world weighed fairly heavily into it, which is, to the credit of Australians, I think.
So, Ari, you've also conducted research for the Royal Australian Navy on the human factors requirements and operations maintenance and training for the future submarines. Can you tell me a bit more about this research?
Yeah, so that was an interesting project. UWA had been doing a number of projects for the Royal Australian Navy, mostly through defence science and technology, for somebody to work particularly on the maintenance aspects of organising maintenance crews on what would be the future submarine. Of course, at the time, that was the French submarine, and it was just at that time being designed, and nobody really quite knew how it would go. And they're trying to anticipate what some of the problems might be with maintenance. And so it's very hard to tell with something that hasn't been designed yet. So the best model we had really was the current Collins-class submarine. And it's no military secret that the Collins submarines had a lot of problems when they were first developed, and even to this day still suffer from quite a number of maintenance problems. So there was a lot of material to work with. In a sense, it was an interesting project and an easy project because there was so much to deal with. And for that project, I applied a technique that I'd worked on and to some extent developed for the original PhD work, which was a mixed methods approach, mixing both qualitative and quantitative analysis of a particular workplace, a particular situation. And I kind of liken it to an onion. You've got layers of the onion and you're peeling various layers away to get to the heart of the onion, the heart of the matter. In the same way, you're alternating qualitative and quantitative data to hone in on what is the important issues to do with a particular workplace and its human factors. So we did that. We gathered data, we interviewed people, we went back and put the interview data in front of people, and then went back again and did more analysis of what people's opinions were. And so bit by bit really got to the heart of where the problems were in the current submarines, and anticipated that in a lot of these cases, problems with a brand new submarine would be equally bad, if not worse, or equally troubling. So it gave us a very good idea of where to look, what sorts of things should be addressed before the submarine even gets into the water, so that they can deal with it virtually straight away, rather than waiting till these things start to emerge 6 to 12 months later and find that you've got, even bigger problem than you might have anticipated. So it was a very interesting project from that point of view. There are actually 4 separate projects that ended up being done. One was specifically on training and looking at new methods of training that might be applied to enhance the human factors that people working, in various aspects of the submarine operation would deal with. So that was quite interesting. Some were purely looking at the issues, the current issues and translating them into what a brand new submarine would involve in terms of issues. And then one was an interesting problem. It was a surface vessel that actually does exist over in, mostly based on the East Coast. And they were particularly interested in getting at some of their maintenance issues, particularly in terms of looking at the people that supplied maintenance workers, the people that came on board from outside and had to do maintenance. So this wasn't particularly the crew, but suppliers then, so that they could be informed as to, where the major issues were. But it was a great project. I found people incredibly cooperative. I mean, the funny thing is with human factors is that when you first mention a project to people that you're going to start, everybody says, oh, they'll never tell you that, or oh, nobody will say anything about that, or they'll be reluctant to speak. And nothing could be further from the truth. I find time and time again, and I've done hundreds of interviews, People really love talking about their workplaces and the work they do. And if there are problems in the workplace, they love talking about that even more. And provided there's nothing particularly sensitive about what they're saying, it's all grist for the mill. It's all material that you can use for the project. And then, as I say, when you start finding patterns in the work, so that's the qualitative basis, when you start to see patterns and start to tote up how often a particular issue gets brought up, and there are various techniques from doing this thematic analysis, that sort of thing, you find that you start to build up a numerical basis for saying that this issue is a much more important issue, a much more critical issue than that issue. And of course, management, the people that run organizations, they love numbers and they love seeing these sort of graphs where they say, well, this is a 20% bigger issue than that one, or 30% of the people mention this as opposed to 15%. And suddenly they've actually got, if you like, a quantitative handle on what the issues are. And then if you want to carry it further, you can start to put those sort of numbers in front of the people that you've spoken to. And then I would typically do much more of a group session, get people together and say, okay, what we're seeing is that this is a big issue compared to this. Why would that be? And then you do another deep dive into why communication might be more of an issue than supervision and training, or why lack of information, lack of procedures, for example, might be a critical information. And then they'll give you much more of the hows and whys and the details. So from that point of view, you can keep going deeper and deeper into it. Whereas if you just, shall I say, stuck at the quantitative level, you've got numbers and the numbers are significant, but a lot of times you don't actually know what those numbers are telling you. Okay, you find out that communication's an issue, but why, where, how is communication an issue? Where are the blockages? Where are the hindrances, so to speak? And so it's that ability to keep going deeper and deeper that actually takes you much closer to the real problem.
And what a great example of how mixed methodologies work in getting the depth, the richness of qualitative data, but putting it in a way that can be measurable. I think it's a really good example of how you need to have both in order to establish more than just correlation and to understand the meaning of the data. That's really interesting.
I think so.
So, Ari, you've talked about a couple of fascinating projects, one on the design of maintenance of submarines and another looking at the human aspects of dependability, which is traditionally in engineering standards. What advice would you have for early career human factors and ergonomics practitioners who might be interested in this sort of field of work?
Well, I think you've heard from some of the stories I've given, some of my own experience, that a lot of it involves being out there in actual workplaces, real workplaces, working with, dare I say it, real people, and people that are, and then people that are up against issues day in and day out. So as some of the human factors people would say, they're working at the pointy end or the sharp end of the business. So what I would say to early career people would be, get out there as much as possible, work in workplaces, work with the workers as much as possible. Somebody in the field of mixed methods called it repopulating psychology. In other words, getting the people back into the psychology. They're not just subjects, they're people, and getting out there and talking to them, working with them, getting a feel for how you get information from them, getting a feel for how much good information they can give you. I mean, I've always been not just surprised, but absolutely astounded at the depth of knowledge that so-called ordinary people have about their workplaces, about the technology they work with, about the faults of the organizations they work with. And all that is gold. All that, if you can get at that, you've got a lot of good information. But at the same time, obviously, as I also said, there's a lot of good theory coming out of human factors. There's a lot of good developmental work. Experimental psychology is telling us a lot. So at the end of the day, it's a question of balance. Try and get as much balance as you can, as much time out in the workforce, but keep looking into the theory, the ideas, why people are coming up with particular approaches to human factors and trying to put those two things together as much as possible. I have to say, unfortunately, a lot of our universities, people working in fields like human factors and engineering have never left the university. And I think that's a bit sad, because I think that they really, truly would benefit from understanding the sort of systems they're dealing with, and also getting in amongst people and educating people that they're working with in the workplace as to the ideas that are coming along as well. So I think both of those are important.
Absolutely. And I think when you talk about industries like mining, submarines, there may be a better understanding of human factors principles. But what advice might you give for those who work in industries which aren't familiar with these sort of principles in design or operations? You know, the less pointy end, but where you need to actually translate these theories and this knowledge and research in human factors into a practical application in an industry where human factors might never have been heard of before. How would you go about that, do you think?
Well, I have to say your word translate is spot on. Translate was the word that I was going to use, so you've really hit the nail on the head with that one. I think a surprising number of industries are not particularly switched on to human factors. I would say it's mainly the high hazard industries, the really critical industries. Aviation obviously is very switched on, transport very switched on, the chemical and processing industry is very switched on, but maybe outside, and even within those industries, it's hit or miss whether you get people that have looked into it, educated themselves. So I think the key to that is, again, your word translate. You're both translating the theory and knowledge to the people that are there. So you're saying, when something comes up, you say, well, in human factors, we would call that a communication error or a systems error, or there might be a systemic problem that you got there. So you're always sort of introducing them. You're in effect educating them in human factors. But by the same token, you're translating things going on in the workplace for them. So if something goes wrong and they pop up and say, well, it was a human error, somebody made a mistake. They said, yes, but that's just the starting point. Why would they have made a mistake? What sort of systems are underpinning that might have gone wrong? Why might there have been weaknesses in the organization that have contributed to that? So you're sort of translating the things that are happening in the workplace, and then again, making them understandable to the people there in terms of human factors, not just something went wrong. Well, okay, but why and how and what does that tell us? And again, it's coming back to that example of the root cause analysis. So you might be involved in a root cause analysis, and people are saying, well, this broke and that didn't, that failed. And then you're saying, well, okay, was there any problem behind it, any organizational problem, human problem behind it? What can we do about that? And invariably, or I can almost say 100% guarantee there will be some systemic human factors issue behind it that could be addressed, and generally far more cheaply than trying to redesign whole systems or re-engineer systems. So, exactly. So I think it's education and translation are the key to it.
And you're definitely helping with that. That's one of the reasons we run these podcasts, is to almost explain really what some people think of as a theory or as an academic idea of human factors and engineering, and actually applying it and explaining how you apply these things in real language, in terminology that people understand. I really like that. Look, we know I've been speaking with a few people on podcasts about challenges which face workplaces in the future, and I've heard some really interesting discussions about the pace of change in technology and even just understanding of theory into practice and how quickly things are changing. What, for you, Ari, do you think are the most significant challenges which face future workplaces, and how do you see human factors and ergonomics professionals, their role in working with these challenges?
One of the big challenges is the introduction of technology, and it's not even just technology as such, but a technical mindset, almost a technocratic mindset. And I've always likened this to a pendulum, and very much in our present day, the pendulum is swung almost entirely towards the technical. And at the other side of the pendulum is the human. And I think even amongst a lot of engineers, there's an idea that if you can engineer the human out of the equation, then things should operate flawlessly. But of course, we know that's not the case. What we know is that it's basically humans that keep all systems running. Without the humans, most systems will just fall over at some point or other. So it's very much trying to bring that understanding of the importance of the human back into the equation. So in other words, bringing the pendulum a little bit further away from the technical end of it back towards the human side. And I think that's a challenge for all of us. But again, as you say, particularly for human factors people, because human factors can be a hard sell. When you do get what I would call hardcore engineers and managers, a lot of times they won't want to know about that. They'll expect people to just do their jobs and the technology will work. If something goes wrong in the technology, it's clearly because some human is stuffed up. And that's not the attitude that we want. The attitude we want is to see that humans underpin from many different aspects of it, whether it's the design of equipment, the maintenance of equipment, the operations of equipment, the refunctioning of equipment, the repurposing of equipment. It's all got humans from one end to the other. And the more we can understand, the more we can communicate that understanding of how important humans are, I think the more that, the pendulum will come back to a much more balanced approach to workplaces, a much more human approach to workplaces. And I have to say, I think a much more functional and a much more reliable and dependable functioning of the workplaces. And this is, again, back to the dependability standard. This is what we're trying to achieve. Trying to get people that, sure, they're engineers, sure, they're project managers, but understand how important the people are to keeping your systems going, especially when things don't go well. It's the human that always brings it back on track. So understand that, and then you will have a much more dependable system. You cannot engineer people out of the equation. It just cannot be done and should not be done. So I think that's the big challenge for everybody in the workplace, and for us human factors, the onus is on us to make that happen, is to bring that understanding and to bring the pendulum back towards a more balanced position. So that as this technology comes in, the AI comes in, the automation comes in, the virtual reality training comes in, it will actually be supported by people properly. So it won't be there for itself. It won't be just another bit of technology that somehow humans have to grapple with. It'll actually work with the people as much as the people will work with it. So I think that's the challenge for us in this current age. And I think AI might make that harder, it might make it easier. I'm not sure if the jury's still out on that, but it's certainly flavor of the month. So we as human factors, as professionals, will certainly have to tackle that one.
Yeah, and you've given us some really good thoughts on how to do that, to get out into the workplace, to communicate the importance of understanding humans, to repopulate psychology. I love that term. Exactly. We almost have a call to action with this to if we are to have a place in making sure that future workplaces are error-proof potentially, or at least being resilient and going back to your word, dependable and reliable, utilising that knowledge. It's a fascinating discussion, Ari, and I was really grateful to hear, particularly about how you moved into this area. What are your thoughts, just before we sign off? Is there any future areas of research you'll be working on? Or is it at the moment just waiting for the baby to be born with the IEC standard?
Right, well, there is a bit of that. I've become very attached to this whole mixed methods approach. I enjoy it and I like it. I like that idea that you can sort of move back and forth and get deeper and deeper into a particular area. And it almost is a challenge to me that there's so much resistance from the traditional quantitative approach. So I like the fact that it is a bit of a disruptive sort of approach, but Yeah, it's something that I look forward to working with more, if there are opportunities to bring that sort of approach to crack sort of more difficult issues.
Well, that's really interesting. I look forward to seeing anything or any more work that you do as you're the honorary research fellow still, and then I'm assuming that there'll be further work to come. Ari, thank you so much for a really interesting discussion. I really appreciate it.
Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.